Welcome you all to the video lecture to the course Computer Organization and Microprocessor. So here in this video lecture, we are going to discuss regarding to the topic which is incorporated in our syllabus. So memory location. So previously we saw regarding to the top topics such as performance measurements as all those things is with respect to our module one. So memory locations. So memory location is nothing that it is a making of a fixed sizing addressable storage unit where it is mentioned means in the computer memory. So simply we can say that a memory location is what a fixed length addressable storage unit. It is placed in the computer memory. So automatically these memory locations will holds some amount of data, which means that of a fixed amount of data. So usually here this can be mentioned in the terms of 1 bytes, which means of 8 bits. So automatically these memory location will have an unique address. Unique address means the one address mentioned to a particular location. That address will not be allocated to the another memory location. So suppose for an example, an instruction move a comma b. This instruction holds as a memory, so memory address, so 1001. So this 1001 will not be given to that of another memory address, another instructions. So each location has an unique address. So these addresses can be mentioned to as an identifier. So for where this identifier is used means the for a memory location. So automatically we can say that this identifier is specifically mentioned for a memory locations. So these expressions can be expressed in terms of, which means that those memory addresses can be expressed in terms of binary or hexadecimal. So where it is used in the processing unit, which means that these things has been accessed or given by the processing unit to in order to locate or mention the data storage at a particular location. So we also have some knowledges regarding to that of byte and bits terms as here these word and bytes is also has been mentioned over this slide. So byte is typically combinations of 8 bits. So those bytes is a group of bytes, which means that a word is a group of bytes. Those word sizes will be purely dependable to that of a processing unit. Such for an example, processor has been of 16 bit of accessing processor, 32 bit and 64 bits of accessing processor. So the byte addressability is usually comes under these memory things. So memory is nothing that usually have a byte addressable. So such for an example, each byte has its own unique addresses, which is also already also I have mentioned here in this every location terms. So the next thing regarding to this memory location is this memory location is automatically, which means how to say this memory location is parallelly or identically equal to the top storage unit with an unique address. So simply we can say this a storage unit with a unique address is nothing that of a memory location. So memory addresses are used normally used to store or to retrieve the data or to manipulate data for particular accessing to a instruction. If for an example I gave an instruction add r1 comma r2, this memory addresses will do this process of storing, retrieving and manipulating of data. So these things has been accessible with respect to that of memory distribution such as fast memory and slow memory. So those accessing and managing of memory efficient is purely a key performance in the computer architecture. So this faster memory and slower memory is like how to say the faster memory it will express it in terms of registers, whereas slower memory is nothing that of a hard drives. So hard drives is those hard drives are hard disk, internal hard disk or SATA hard disk, all things is comes under this lower memory. The faster memory is nothing that of register. Example we can say that as a register. So the next thing we are going to see regarding to this memory location here is this memory can be it is a combination of how to say the storageable cells. Those storageable cells are comparatively combined with of many millions of storage cells, each of which can be stores of how the bits of data having a value of zeros and ones, since it is a digital value. So those things has been expressed over in the zeros and ones. So this group of n bytes gives us a value, gives us the word of information. Those things as word of information is nothing called as a word length. So the thing which we need to get concentrated over here is the this memory is consists of many millions of storage cells, group of n bits. So that group of n bits will replicate to the top word of information. That word of information says as an n value. That n value is called as a word length. So the automatically the memory of a computer can be schematically represents as what, a collections of words. So this things is has been covered over in this memory location in this slide. So the next slide says is how this memory location, which means that how the word representations are has been mentioned. Here the first word indicates is over to the top first block, second to the end the block, and the last word. So word length or the word representation will automatically represented over here like this. So we can able to say how the words has been allocated, which means that these allocations are done as per with respect to the top what thing. We already see that the memory address. So automatically the first word and second word and eighth and the last word will accessing that memory locations. So that locations has been described with respect to the top what address. So that the address represents the first word, particular address. The next address represents the second word. So eighth word also has some address. So automatically these things has been represented over with respect to the top a memory address. So automatically the word first word has an unique address, second, third, and the fourth or eighth word are the last word. These things has a particular addresses. So the next slide we are see accordingly to the top the memory locations. So the memory locations says us with respect to the top already we saw in our classrooms explanation also ASCII characters. So how to express this means, if suppose we can have ASCII characters as of example here a 32-bit processor or an 64-bit processor with a combination means how this representation done means, if suppose 8, so 1 bytes carries of 8 bits, so 1 4 bytes, so 4 into 8 gives a values of 32. So the 32 bit has us the memory location of around 4 bytes. So automatically suppose in the next slide we can able to see that here this I said this regarding to the ASCII characters. So here unit of 8 bits is composes half of the byte values. So automatically the instruction may carry of one or more words, so for their representation. So here the machine instructs us how one or more is required for this representations has been mentioned over here. So simply we can say this, a computer have a word length that typically ranges from where to where means from 16 to 64 bits. For 32 bits, this is the representation. For 64 means we need to give another 4 blocks. So automatically it has of these types these things is. So automatically how many bytes is representation here come means 8 bytes of representation for 64 bits. For 32 the 4 bytes. For 16 2 bytes. So this is the normal confirmation of a word length. Typically ranges to the top how to 16 to 64. So the next is the memory locations with respect to the top address space. So address spaces here it will say us regarding following that byte addressability. So byte addressabilities and memory operations is also upcoming things. So the byte addressability here represents with respect to that of big Indian and little Indian. So here in the lab classes we discuss regarding to that of big and little Indian, which means that example I annex some address given means 4200. This representation, which means that INS has an opcode value 32. Just for an example, this is not an exact opcode value. So the next representations will be based with respect to that of little and bit Indian assignments. So normally an Intel processor will be based with respect to that of what means the least significant value will be placed first and then the most significant value. So if suppose for an example the processor introduced before after to that of Intel such as Motorola based processors will give accessing of first we are placing the most Indian significant beta, which means that the big Indian assignments has been done. So this little Indian assignment and the big Indian assignments has been typically has a major role in the byte addressability. So this byte addressability will have accessing of this assignments such as big Indian and little Indian. So this big Indian and little Indian has these things as a definition says us that use it when the lower byte address are used for more significant bits, which is big Indian. So little Indian says is that it is an opposite order to that of little Indian. So these things is comes under over this the byte addressability. Thank you.